Hello, this is Kai again. Welcome to another video of CS106A assignment solutions. This one is assignment 1 problem 3. You would have to deal with a problem called a CheckerboardKarel. And in CheckerboardKarel, what you're supposed to do is fill up a whole entire space with beepers in a checkerboard fashion. And basically what they want you to do is to make it into a checkerboard, but the twist is that make it work for any type of world. So if I were to make it 3x5, 8x8, 5x9, 11x11, it would be able to create a whole world of beepers. And so let's get right into it. Okay, so again, if you haven't already seen it, you probably want to take a look at your little cheat sheet right here to kind of help you figure out how to create this world, this checkerboard world. Again, you see you have the basic packages with the extension of the CheckerboardKarel, and we got to fill in our blank right here. So what we're going to do is we're going to put in the public void run statement right there. Okay. And now we're going to figure out how to create this checkerboard world. Okay, so the first thing that you probably want to do is you want to go ahead and start dropping beepers. Okay, so in this whole entire world, you want to start dropping beepers. And there's so many different algorithms you can use to create this. It looks like the positioning of Karel at the end really doesn't matter as long as you have the checkerboard shape. But you can create Karel going forward like this, and a corner, and a corner, and a corner, and kind of like zoom in like a snake, or you can just have Karel go back and forth, back and forth, back and forth, back and forth, and that's also fine as well. And basically, for me, I am going to create a Karel that moves back and forth, back and forth, back and forth. Okay, so the first thing I need to do is create my stub, right? So the method that I want to use is place checkers. So place checkers, sure. And we create the method for that. So I'll create it as a private void place checkers. I don't really have a good name for that. And after he places the checkers, he needs to check to see if there is, if he needs to switch to another row. And so what we're going to do here is once he gets to the end, okay, once you place the checkers, he needs to be able to move to the next row. So we're going to go move next, okay, and we're going to create the stub for that. I'm just going to call it private void move next, just like that. Okay, so we have place checkers and move next, and basically boom, 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 boom. That's all we need. Okay, so the cool thing is that we need to be able to create variables that can be used in these methods, not just in the method, but rather in the whole program, if we want to have it used. And so what I'm going to go ahead and introduce, well actually maybe I'll just introduce it when it comes, but basically we just need to have these interact with each other in order to create this checkerboard. Of course you don't have to, it's just the way I'm doing it, but anyways, let's go ahead and get started. So place checkers. So the way I'm going to do this is I'm going to use a math operation. My favorite kind of math operation is, I guess we can use the remainder operator. So what I'm going to do is I'm going to go ahead and say while front is clear, while front is clear, we're going to go ahead and have Karel do what? We're going to drop a beeper, or not drop, actually drop a beeper, but we want to be able to put the beeper. Okay, now notice how if the front is clear all the time, it's going to drop the beeper all the time. So we want to put a condition on that so that it would not put it all the time. So let's go ahead and put a counter. Okay, so I'm going to create a counter, and it's going to be an int and remainder 2. Okay. What this does is that if there's like a number like 1, remainder 2, what it does, it tells you that there's a remainder of 1. See, if counter was 2, remainder of 2, then the remainder would be 0. So if counter was 3, again, remainder of 2, counter of 3, remainder of 2 would give you a remainder of 1. So basically, it's the remainder every time you divide the number by that gets returned. So let's say if the counter remainder of 2 is equal to, doesn't really matter, let's say 0, okay, then what we're going to have Karel do is put the beeper down. Okay, so every time you get a remainder of 0 for the counter, then it will drop a beeper. And when it's not 0, it won't drop a beeper. So as you can see, it's going to be every other number. Now what you're going to do is we're going to go ahead and put that counter, initialize that variable right here. We're going to call it private and counter, initialize it as 0, so that we can have a running total of the value of counter. Now, of course, after it drops the beeper, okay, we want to have that counter increase, so we can have a running total of the count. So if the count is at 0, it's going to drop the beeper, and the count will go up. And then once it's at the next spot, it will be a remainder of 1, and so it won't drop a beeper, but the counter will go up. And with that counter moving up, we also want to make sure that Karel is also moving forward. So you have it as, while this Karel is free to move, so front is cleared, it will go ahead and see if it will drop a beeper. So since counter is 0, it will be equal to 0, so it will drop a beeper. Then the counter will increase, and then Karel will move forward. Then it's going to cycle again. This time counter is going to be equal to 1, so 1 remainder of 2 is going to be 1, so it does not put a beeper. And it's going to go ahead and add the counter and move again, drop the beeper, no beeper, beeper, no beeper, beeper, and then once it moves forward, remember, it's going to break out of the while loop, and it's going to say if it's going to be a beeper or no beeper. And so once it hits here, we want to make sure that it does go ahead and does this whole thing right here again to check if the counter is at the right count. So if the counter again is even, it will drop the beeper. If it's not even in this spot right here, it will not drop a beeper. But regardless, we need to check that last spot to see if it's working. Okay, so that was just that one method right there. Again, this is just one algorithm of doing it, one way of doing this, one algorithm. So if you have another algorithm that works, that's also fine, but in this video we're just working with this method. Now, once we place that checker for that one row, again, I want to move to the next one. So to move to the next one, what we're going to do is we're going to have Karel move to, move up by 1. So we want Karel to move up by 1 and then turn around. Okay, so how do we do that? Well, again, we're going to go ahead and go to our method right here. It's called move next, and we're going to go ahead and say, okay, so if he's facing east, if Karel is facing east, so facing east is one of the conditions. What do you want him to do? You want him to turn left, move, and then turn left again. So that way, Once he's here, he's going to turn left, move, and turn left again. And we can do that because the condition of facing east is what causes him to move in that direction. Now I understand that when we cycle this again and he's moving east and he places those beepers down again, here he's not facing east, right? And so in that case we need to create an else if in this case. We could have used an else because in this case he's going to be, you know, moving in a left-right pattern, left-right pattern, left-right pattern. So I could use else because there's only one other condition, but you know, just to kind of like be a little specific here, I would say else if Karel is facing west, I would like him to turn right and then move and then turn right again, just like that. And so therefore, once he turns right, moves, and turns right again, he'll place those beepers, turn left, place those beepers, turn right, place those beepers, left, right, left, and he's done. And basically, once he gets to the end, again, it doesn't really matter, but that little red box will maybe pop up saying that, oh, Karel was blocked, and then it'll just end. Otherwise, if you don't want to see that, you can create an if statement that would break out of it. Again, looking at our program, the place checkers only executes once, and the move next executes once. And so I told you from the last video, the trick is we can use a while true in order to make this happen forever, right? So move, boom, forever. Okay, so basically when we run the program like this, like so, we'll go to CheckerboardKarel, see how there's an 8x8 world. We'll start the program and voila, look at that, just makes that little block right there of checkerboards stuff. So if I were to change my world, let's go ahead and change it to a 1x8. Start the program, boom, another checkerboard version of a 1x8. Load it again, 6x5. Look at that, again working for a 6x5. 7x7. And again, works for a 7x7. Yeah, that red box can be annoying. Boom, that was 8x1. 8x8, that's the one we did in the first place. And then if you want to do a 40x40, and of course you can fluctuate in terms of how fast you want this guy to work. So we started, he's going at a blazingly fast pace, and then we can just increase the speed a little bit and he can just start zipping. Look at him, just zipping. Whoa, just zipping. There we go. And you see that's the purpose of creating a very generic algorithm so that Karel can build a checkerboard in any situation. And there you go. That's the solution for assignment 1, problem 3. If you liked the video, please subscribe and like, and I'll see you next time.